Hey, the average Joe here. Hey, I was asked recently about building a mechanical front end system for a Snowmelt project. So let's just do that here. The best way to do that is to come to one of our wizards. There's 8 of them here. And we're going to start off by using the hydronic fluid separation subsystem. So we're going to answer the questions here and build that system. We want to do a heating only system. We'll build for connecting loads to a primary generation loop. Have that checked. We default to 2 heat exchangers at 100%, but we could make each one 50% if we wanted. Propylene glycol, you see you can change that as well, 30%. Plate and frame heat exchangers, well, some other ones there, choices. We'll do some multi-purpose valves and some control valves. Would like to do 2 pumps. We can do those at 50%, so we made the heat exchangers 50%. Same thing with the transfer pumps. We'll go with the Taco KS series. One glycol feed, we have Axiom in here, and you can see we have different choices of all the different feeder systems which they make. Then one expansion tank, one air separator. And there is my 2 heat exchangers with the related pumps. So now all we need to do is come over here. We'll go up to the hydronic toolbar on the top and just grab a boiler. Let's grab a Cleaver-Brooks boiler here, clear fire. Come over there and set that down. We get a component for the natural gas piping associated with that boiler. We'll do the supply right there, connect that into the system. Just click on that. We'll do the return up there, connect in. Then now since I set a Snowmelt system, I'm going to come to the imposed load. And all these imposed loads, remember, they're just different pictures. So there's fan coils and radiant sealing. We'll go down to Snowmelt. So it's just a different picture. I can come in there, component, click on that, type in a load, so many BTUs. So a Snowmelt system, you'd have like 100 BTUs per square foot on maybe a typical system. Multiply that by your area. We'll come with 1,000,000 there, put that in, connect that into the system, do the return. So based on that load, the delta T of 20 degrees there, you'll see we have all our flows. Let's just make sure we got the right load there. That 1,000,000, 1, 2, 3, 1, 2, 3, 1,000,000, yes. So based on the delta T, we have all the flows associated with that. Transferred down to the boiler. We just have one boiler, so that's got the load of the 1,000,000. So now if you want to take this a step further, you could come in the Radiant Hydronic 2 toolbar, and we also have the Vega hydronic manifolds. So you can grab however many ports you want on that. You'll see, and with that, you get a shutoff valve, balancing valve, flow meter. So that's a typical, and then I could come in here and hook that up to the supply and return, and then take the zones and show those going to an imposed load. Now the piping itself, the circuitry, like in the slab itself, I'd recommend you use something like LoopCAD, Watts Radiant, something like that, that does the layout on that. But once you know that layout, or if you're just going to estimate it with so many BTUs per square foot, then you can do that and impose that load into the system. So anyway, just a nice way to use our hydronic fluid separation subsystem wizard. You can get different types of heat exchangers, number of heat exchangers, pumps as well. A lot of times when I do a project with the Snowmelt, I always did redundancy on that. So anyway, hey, hope this has been helpful, and thanks for watching.